Hello students, welcome back. Let's resume our discussion in section 6, Undetermined Functions. First, we went through these kind of expressions where the function values and derivatives at specific x values, x equals to 2 in this case. In that case, we can use usual derivative addition rule, coefficient rule, product rule, quotient rule, and some further computations associated to those. Yeah, we can do that, but no chain rule. For chain rule, we need a little bit more, because if you calculate the composite function, inside will take different value, so I have to move out of just first x value. First x value is 1, but just the first column here is not going to be enough because I end up moving out of there. G of 1 is 2, so we need the entire table. Same thing goes here as well. X is 1, but f of x is not 1. It goes outside of this, so go to 3 and so on and so forth. So you have to read the entire table. This time we don't need g, just f of f. So chain rule for f only. Still, x value does not stay at x equals to 2 only. Inside, f of 2 is not 2. You have to move someplace else. So we need the entire table. Similar thing goes for G composition G. And then, of course, I can give you F composition G, kind of like those two. But I have to be careful, because if I don't be careful, I may go out of bound in this table. The algebraic expressions of f and g are not there, they're undetermined. Just a few point values are there. So if I go out of bound, then you cannot solve this problem. In any case, coupled with some derivative rules and some function values and derivative values in a certain table, we can answer all these when the functions are undetermined. Now let's do the same with graphs. Oh, sorry about that. Wrong cell. Okay, here we go. Alright, we have this graph. Y equals f of x is this red graph. Y equals g of x is this blue graph. Red graph here has some curved portion and line segment portion. G of x is entirely out of line segment portion. So the derivative computation is going to be pretty much okay here. What's the slope here? It's constant. What's the slope here? What's the slope here? Those are all good. And estimating slope over here will be a bit of a challenge. We'll see. Define the functions PQ and UV like this, product, quotient, and then composite functions U and V respectively. Alright, what's P prime? Let's copy and paste this picture so that I don't have to move too much away from this. P prime of 2. Well, P is F times G, so we can use the product rule. P prime of x is F prime of x, G of x, plus F of x, G prime of x, and therefore P prime of 2 is F prime of 2, G of 2, plus F of 2, G prime of 2. So, can you find F prime of 2 from this picture? X equal to 2, F prime of 2 right here. What's the slope of the tangent line here? We have a horizontal tangent. So this thing is going to be 0. Do you see that? This is going to be 0. How about g of 2? Function value right here, y-coordinate. That's going to be 2. Well, not that it matters. 0 times something will disappear anyway. How about f of 2? Function value is y-coordinate. Height is 3. G prime of 2 at x equal to 2, slope, that's the derivative. That's 1/2. So I'm getting 3/2. Is that clear to you? Just reading the graph at x equal to 2. Not just the graph, but also the slope. Yep, the same computation. Now, can you do the same thing to quotient? Quotient, f over g, take the derivative, you're going to get a quotient rule, and then plug in x equal to 7. Around x equal to 7, what do you have? 1, 2, 3, 4, 5, 6, 7. Right here. Function value is y-coordinate, that y-coordinate. The derivative says this slope and that slope. Right here and right there. We know everything precisely. That's easy. Quotient rule, and then evaluate it at x equals 7. F prime of 7 is this slope, 1/4. 1, 2, 3, 4 steps and 1 step, yes. And times 1, that's height. Minus f of 7, this height, 5. G prime of 7, the slope here. 1, 2, 3 steps to the right, 2 steps down, so negative 2/3. We have it here, and do your computation. Can't read? Expand the font maybe. Okay, alright. Those two are easy, and of course, remember, I can give you many other expressions. It's just that I have to be careful that they fall inside the graph. Next, u is a composite function, f of g of t. So let's use a chain rule. U prime of x, u prime of x is the derivative of this composite function. So step 1, outside function, inside never changes, and then you have to multiply the derivative of the inside. Alright? Okay, alright. Now how about u prime of 2? So x equals to 2, x equals to 2, and then x equals to 2. Okay, alright, let's copy and paste this thing, and let's do the algebra. Differentiation is done, so outside in, that part is done. Now inside out. Inside, what is g of t? X value is 2, x coordinate is 2, function value is y coordinate. Right here, g of 2 is this height, 2. See that from the graph. Okay. Now, what is f prime of 2? That height. Oh no, excuse me, f prime of 2. That slope, right here. That's 0. And then g prime of 2 is that just slope here. It's going to be 1/2, but it doesn't matter. We get 0. 0 times something is 0. Here's the computation. We end up with 0. F prime of 2 right here, that's 0. Luckily, we didn't have to do any estimation. Okay, final question here. V is g of f of x so the derivative is v prime of x is, by chain rule, the derivative of the outer function. Inside never changes. And then multiply the derivative of the inside function. Like a dangling chain. All good? Okay, alright. From here, we are looking for what? V prime of 1. So x equals 1. X equals 1. Okay, alright. Let's go ahead and find this. We did the calculus. Outside function first. Inside doesn't change. And the chain part. Derivative of the inside here. So outside in, we are done with those. Now algebra. Inside out. Inside first. What is f of 1? Let's copy and paste this thing. And then tell me, what is f of 1? 1, 2, 3, 4. So f of 1 is 4. Is that right? So f of 1 here is 4. Did I get it right? Function value is 4. Alright? Okay. Now, what is g prime of 4? 1, 2, 3. It's right here. 1, 2, 3, 4. 4 is here, right here. What's the derivative here? It's a cusp point. This is undefined. And then f prime of 1, I don't care, this is undefined. So undefined times something, that's undefined. F prime of 1 is a derivative here. It's something negative, the derivative exists. But luckily, you don't really have to worry about estimating this. Because that's undefined here. So undefined by something. So yes, it's undefined. You're going to this cusp here. Okay, alright. We went through some graph problems associated to the chain rule and quotient rule and product rule as well. And all those are problems regarding undetermined functions. You don't have the algebraic expression. You just know the function values and the derivative values at specific points. Otherwise, maybe you have to do some estimations, but not even that. What do you actually do? Well, you gotta use the derivative rules and some minimal computation, and then you can answer those kind of questions there. That completes all the problems I prepared here in this lesson, and that concludes the chain rule.